This is 9.9. This is an interesting section. You start out with a function, like f of x is equal 4 over x plus 2, centered at some kind of number. And you want to rewrite that into the geometric power series form. So a over 1 minus r. And then from there, you can deduce what r is and plug it into this formula right here. The summation of n equals 0 to infinity a r sub n. Tricky part is to put it in that right form. So I came up with these steps this afternoon. Hopefully they work all the time. I went through and worked every one of the odd ones, and they worked on every one of them. So I figure that's as good as I can test it. But if you got a rational function of this form, d over e plus x, where d and e are a number, and the plus, it doesn't have to be a plus, you could have a minus there too. But you want to rewrite that into geometric power series centered at the 0. Now, case 1 is where you have a sign between e and the sign between e and variable term is positive, where you got e plus x. Case 2 is where you got sign between e and the variable term is negative, like e minus x. Now, if it's case 1, you divide everything by e, rewrite the plus as a negative parentheses negative. Case 2, you just simply divide everything by e. So let's take a look at this problem. Number 3, got f of x is equal to 1 over 4 minus x. Okay, so we want our x second. So d is a number on top. So d is 1. The e will equal 4. And we got a minus. So that's case 2. Sign between e and the variable term is negative. All we do is simply divide everything by e. So I'm going to divide everything by 4. So I got 1 over 4, 4 over 4, minus x over 4. So it gives us 1/4, 1 minus x over 4. Now our formula, let me find it. What is this, number 3? 1 over a over 1 minus r. I should have that written down in the steps, but so a is a number on top. The r is going to be x over 4. Actually, I have this in the PowerPoint. So I decided I got tired of flipping around. There's A, 1 minus R. Okay, and so conditions convergence, if you're talking about geometric, the absolute value of R is less than 1. Now, these are a little bit easier in the last section because we don't have to check the endpoints. Because if it's geometric, that's all we have to check. We just said R was x over 4. So from college algebra, we can rewrite it this way, multiply everything by 4. That'd be our interval of convergence. Those indicate that it doesn't include those values versus brackets. It's actually interval notation. The less than's here is what tells me parentheses. Now, here's our geometric series. If you got it in this form, then you can rewrite it in this form. So n equals 0 to infinity of a r sub n. So n equals 0 to infinity. A is 1/4. R is x over 4 to the n power. So if I plug in 0, I have 1/4 x over 4 to the 0 power plus 1/4. Though I could put the 1/4 clear out in front, couldn't I? And this would be x over 4 to the first power. This is x over 4 squared. One over 4 minus x. So I could divide 1 by 4 minus x. You look at the 4, you ask yourself what times the 4 gives you 1. And that would give us 1/4, right? 1/4 times 4 is 1. 1/4 times negative x, negative 1/4 x. If I subtract that line, that flips signs. So it becomes positive 1/4 x. Now I'm probably going to screw this up. I'm going to multiply this, the negative x, by a negative 1/4. Well, let me show you what it should look like. I'm not going to be able to do that. I'll screw it up. What if they have it in CalChat? Wasn't even close. X over 16. 1/4 multiply times that. It gives you 1 minus x over 4. Then it gives you x over 4. Oh, you still look at the 4. That's what I did wrong. Okay. So you ask yourself, what times the 4 gives you the 1/4 x? and that's 1/16x. 1/16x times 4 is 4/16 or 1/4 x. 1/16x times negative x is negative 1/16 x squared. Subtract that. That's going to give us a positive 1/16 x squared. Now you're looking at the 4 and you're asking, what do I multiply it by to get this? 1/64 x squared. And 1/64 x squared times 4 gives me 4/64 or 1/16 x squared. 1/64 x squared times negative x is negative 1/64 x to the third. And then you continue on to infinity. Now what they're asking in this problem, they want us to do it this way, show how we can rewrite our function so it's in the right form. And if you look at these terms I did up here, you may have noticed they give you the same thing as this here. So there's two ways you can get that summation. You can rewrite in geometric form and then plug it in here, or you can do long division. You see here, it says find a geometric power series for the function centered at 0 by the technique shown in examples 1 and 2 and by long division. So the first one is what we did with the rewriting in that form, and then the second part is long division. Now don't worry about long division for homework or for tests or quizzes or anything like that. As you can see, I'm not very skilled at it. I can do regular long division pretty good, but when you start, what do you multiply by to get a fraction, it starts throwing me. Okay. Let's take a look at another one of those. Number 5. Okay, we're not going to do the long division because it gets even worse here. You know, you ask, what do you multiply times 3? They'll give you 4, and then it starts getting nastier and so forth. Okay. Back to this. D is the number on top. D is 4. E is the constant on the bottom, constant term. And this has a plus between it. The plus between it is case 1. The sign between E and the variable term is positive. So first thing we do is divide everything by E. So we divide everything by 3. So I got 4/3 over 3/3 plus x over 3. Now the reason why we do that is because the geometric says, what does it say? A over 1 minus r. So it says you have to have a 1 here. So that's why we create that. Even more than that, it says there has to be a minus in between them. So rewrite the plus as minus minus. So it's going to be 4/3, 1 minus a negative x over 3. And so from our form, this would be A, and this would be R. And it tells us that converges when the absolute value of negative x over 3, R, is less than 1. Now the absolute value I can just drop and put into my form. And also I can drop the negative. So I got negative 1 is less than x over 3 is less than positive 1. Multiply everything by 3. I get this. So the radius of convergence is negative 3, positive 3. Good so far? Okay. Now this is the harder form, but still not too hard with the instructions I've come up with, I don't think. Rewriting a rational function of this form. F of x equals d over e plus fx. The key to this form is you got a number in front of your x. So that's what makes this difference. And it may not be centered at 0. We're going to do nothing as a test. To say negative c, but I think. So what do you do at a positive c? I think I can just change it to c. Okay, we'll see if that works. They're not hard problems, at least down to that point. Okay, find g using this formula. G is equal to E plus F times C by plugging the values for E, F, and C and then simplifying. Rewrite the divisional function using this form. Divide everything by G. It gives you this. And if the sign between 1 and F divided by G in the denominator is positive, then change it to negative and change the X plus C to negative X minus C.
What is the says now it's centered?
Centered at for English. Centered at C. Originally, I was thinking I was going to have 2 slides for this, centered at negative C and centered at positive C. But then when I was working the problems, it's like it was working, the steps I'd come up with were working on both types. So it's like, oh, this doesn't seem to matter. Let's see if that's a true statement. Okay, so let's take a look at our first problem. And take a look at number 7. Although this isn't much different, but still enough because it's not centered at 0. Okay, C is equal to 1. So let's identify everything first. D is a number on top. So D is 1. E is that constant term down there, so E is 6. F is whatever number is in front of the X, negative 1. And C is given, so C is equal to 1. Okay, so step 1. Find G using this formula. G is equal to E plus FC. E is 6. F is negative 1 times C, which is 1. 6 minus 1 gives us 5. Step 2, rewrite the original function in this form. F of x is equal to d was 1, over g was 5, plus f is negative 1, x minus c, so x minus 1, and let's look at that real quick. I've changed my steps. I don't feel so confident. Okay, that looks good. This is step 3 now. It says divide everything by g. Well, g was 5. So I'm going to have 1/5 over 5 divided by 5 minus, you can drop the 1 if you want, x minus 1 over 5. Remember, our goal was this. So I'm going to have 1/5 over 1 minus x minus 1 over 5. So this would be our r, and this would be our a. Now, I don't know if they want the actual summation form. Let me see. Yeah, I guess they do have it here. But your summation form would be n equals 0 to infinity, a times r to the n. A, we said, was 1/5. R is x minus 1 over 5 to the nth power. Now, that's that part. The okay, that's the find a power series for the function. So that's what we just did there. Second part is determine the interval of convergence. And since this is geometric, again, geometric goes back to the absolute value of r is less than 1. So the absolute value of r is less than 1. I can drop the absolute value and put it in this form. Negative 1 is less than x minus 1 over 5 is less than 1. Multiply everything by 5, and I get negative 5 is less than x minus 1 is less than positive 5. Add 1 to all three sides, and you get negative 4 is less than x is less than 6. So that'd be negative 4 to 6.
What's the point of doing this?
I don't know. It's not really used right here. You're correct. I suppose if you want to program it, then this isn't a good form to develop a graph, see a pattern, and so forth. But beyond programming, I don't know why. Because we got our radius of convergence.
We're trying to find, so yeah, we're just finding another.
Yeah, because it seems like, well, you started with something that's so easy from college algebra, and you're making it something totally hard. And I couldn't tell you. But I'm sure you'll see it in future math classes. Yeah, it seems like, well, wouldn't we want to go this way and get the other functions? This lies easier to work with. Let's take a look at number 9. F of x is equal to 1 over 1 minus 3x, and centered at 0. Okay. Back to these steps. Identify your E, D, and F. So D is a number on top, which is 1. E is a constant term on the bottom, so the E is 1. F is a number in front, which is -3. And obviously C is 0. Now I'm going to go through this, but since it's centered at 0, we could have used that previous definition I gave you. It'd be easier. But I didn't actually test it with this formula, so I'm curious if it'll work. Find G using this formula. G is equal to E plus FC. In theory, it should. So I got 1 minus 3 times C, which is 0, which gives us 1. Step 2, rewrite it as D. D is 1 over G. G we said was 1. F. F is -3. And then X minus C. So X minus 0. And we're back to where we started. Like I said, when it's centered at 0, it's kind of a different beast. You can use those steps I had before. Okay, step 3. Divide everything by G. G is 1. So again, it does not change it, does it? And our goal was this, which we're there. So this is R. R is equal to 3x. This is A. So summation n equals 0 to infinity of A R to the n, I think it was. A is 1. I don't know what to put it, I guess. And then R, which is 3x to the n. Now again, geometric converges when the absolute value of R is less than 1, and we said R was equal to 3x. So get that, drop the absolute value, put it in this form. Divide both sides, divide everything by 3. And we get -1/3 to +1/3. I can almost get rid of that first slide. This works for 100% of them, doesn't it? Of course, it has 2 steps that don't do anything. But that's okay. Let's look at number 11. G of x equals 5 for 2x minus 3, and C is equal to -3. Okay. Really, I guess the first step would be to identify D, E, and F. Identify D, E, and F. Okay, so D is 5. E would be -3. F is whatever number's in front of our X, which is 2. And obviously C is -3. So that's step 1. Step 2, G is equal to E plus FC. E is -3 plus F, which is 2, times C, which is -3, which gives us -9. And step 3, rewrite in that form. F of X is equal to D. D was 5 over G. G is -9 plus F. F was 2. X minus C. So X minus a -3. So give us 5 over -9 plus 2 times X plus 3. Step 4, divide everything by G. G was -9. So 5 divided by -9. -9 divided by -9. Plus 2 divided by -9. X plus 3. So it gives us -5/9. 1 minus 2/9. X plus 3. I haven't been asked. I haven't been doing step 5, have I? We haven't had it yet. The sign between 1 and F divided by G in the denominator is positive. It's negative, so we don't have to do that. Okay. Basically, you just have to have 1 minus there, because this has to be in the form of A, 1 minus R. So this would be R, and this would be A. What?
An entire thing would be R?
Yeah.
Including? No, not including that.
Yeah, not negative. So our form here is A, R to the N. So A is -5/9. R is 2/9 X plus 3. Or you could do X, you could merge those a little bit more if you wanted, the N. And where the interval where it converges, you take your absolute value of 2/9 X plus 3 is less than 1, because geometric series says absolute value of R is less than 1. Okay. -1 is less than 2/9 X plus 3. It's less than 1. Multiply everything by 9/2. -9/2 is less than X plus 3 is less than 9/2. Subtract 3 from all three sides. -9/2 minus 3 is less than X is less than 9/2 minus 3. What's that? -15 over 2 is less than X is less than 3/2. 6 over 2, yeah, 3/2. So that would be -15/2 to 3/2. Does that make sense how to use that formula? Let's go on to the next type. I want to show like number 15. I'm going to g of x is equal to 4x over x squared plus 2x minus 3. If you have a quadratic function in the denominator, then try the following. So we're going to factor the denominator. So 4x x squared plus 2x minus 3. This becomes 4x over x plus 3, x minus 1. Rewrite the single fraction as two fractions using partial fractions. Remember, partial fractions for linear, we put a over x plus 3, and we put b over x minus 1. We multiply everything by x plus 3, x minus 1, and we get 4x is equal to a times x minus 1 plus b times x plus 3. It gives us ax minus a plus bx plus 3b. So I got ax plus bx, negative a plus 3b. And remember, we factor out an x, and I'll put it behind it. So I got a plus bx, and then we got negative a plus 3b. So I'm going to equate what's in front of the x's. So I got a plus b is equal to 4. And I equate this to my constant. There is no constant over here, so it's 0. So I got negative a plus 3b is equal to 0. Add those. A minus a drops away. B plus 3b is 4b. 4 plus 0 is 4. Divide both sides by 4, and we get b is equal to 1. And if we plug it in back into here, a plus b is equal to 4. That gives us a plus 1 is equal to 4, or a is equal to 3. Which means our function we can rewrite as 3 over x plus 3, and b is 1 over x minus 1. Rewrite both of them into the geometric series using the steps I gave you up above. In this case, I think my first form I gave you should work on both of them, because they're pretty basic. Okay, so this one here, x plus 3, there's a plus between them. So sign between e and the variable term is positive. So divide everything by e. Let me rewrite that. Usually the numbers first. Okay, so for this one, I'll divide everything by e. So I divide everything by 3. So 3 divided by 3, 3 divided by 3 plus x over 3. gives us 1 over 1 plus x over 3. Now my second one, I guess this got a plus between the two, doesn't it? So sign between is positive, divide everything by e. So I'm going to divide everything by -1. So 1 divided by -1 over -1 divided by -1 plus x divided by -1. So I got -1 over 1 minus x. And that actually just changed the other type, didn't it? Because it's got a minus between it, which is what we want. Because remember, our form is a over 1 minus r. So back to my first one here. It says, rewrite the plus as negative, parentheses negative. So this will be 1 minus negative x over 3. And this one's already a minus, so I'm good there. So on this one, this would be my r. This one would be my a. I can actually take that minus and put it out in front, which we'll see. But this would be my a, and this would be my r. Remember, our form is n equals 0 to infinity, a, was it r to the n? So this one becomes n equals 0 to infinity. A is 1, so I can drop away. R, negative x over 3 to the n power. I can put the minus out in front. And this would be a, which is 1, so it kind of drops away. And this would be x to the n. Now, basically, if you got a function plus another function or minus a function, and you're working these type of problems, you can put them in a single summation. So that says we can just merge them together. Assuming your x to the n is outside of these. Well, let's see if we can rewrite it as outside.
Would that be necessary though?
It would by the formula. Because I'm thinking if you can't rewrite it as x to the n power on the outside, then you probably can't do that. So, but this one, I can take the -1 to the n power, I can take the x to the n power, and I can take the 3 to the n, or 3 to the n power. And now, it is outside, isn't it? Now, from our first part, applying it strictly by our formula, the a sub n does not include the x to the n. So on this one, the a sub n is equal to -1 to the n power over 3 to the n. On this one, the b sub n is equal to 1, isn't it? Because there's nothing there except for the x to the n. So when we merge these together, I'm going to have a sub n plus or minus b sub n. So I'm going to have -1 to the n over 3 to the n minus 1 x sub n. Now at that point, in terms of the quiz, tests, and so forth, I'll have you stop right there. To me, that's a part that then becomes quite challenging, like number 15. Interval convergence? No, don't worry about that when you got a quadratic down there. Now, I think I developed a pattern that I see, and it seemed to work on every problem, but there's no formula, no theorem I could find that said I could do it. My thought was, before I erased it from the PowerPoint, was that up here, you find the interval of convergence of each one. You do this one, and you do this one. And of course, the negative would drop away here, and you'd end up with -3 is less than x is less than 3. This one, you'd end up with -1 is less than x is less than +1. So this one goes from -3 to +3. This one goes, and shade it. This one goes from -1 to +1 and shade it. And where they intersect would be your radius of convergence. So that'd be -1 to +1. And that's almost what they imply here. You see how they got this, and then that says that implies -1, +1. But then you go to number 17, and they don't do that. Because number 17, I did the same way, and it works, by the way. Number 17, I got the correct answer. But again, I'm a little leery, even though that problem number 15 indicated you could, because I could not find anything in the book that said that your interval of convergence would be the intersection of the two. I remember when I was taking count 1, 2, or 3, I forget what it was, and took a test. I had the right answer, and I'd done it a short way. And the key the instructor had was a really lengthy way, and he counted off a lot of points on that problem. It's like, what? I got it right, and I just didn't do it the hard way like you did. And I went up and asked him, and he said, well, yeah, you got the correct answer there, but it only works for that specific case. So I'm a little leery if I don't find anything that tells me I can do that. Anyway, now the last topic in this, I'm gonna mention it, but I'm not gonna assign anything on it because I don't like it. See, down here doesn't say anything about the interval of those. What you do here is you start out, see our function is natural log of x. And you start out with the derivative of that. So taking the derivative, you then integrate that. And once you integrate that, you come up with this by the formula, and I'll show you the formula. Well, that was a formula off the previous one. But you come up with this formula here, and then from there, C is equal to 0. You can come up with the power series. Well, that seems very specific when you can use that. When you're taking a derivative of something and it gives you something that's already in the correct form. So I don't really like that. If you want, you're welcome to look at that, but I'm not going to assign any of those. That seems too specific. I mean, even these ones we just looked at look kind of specific, don't they? Like you can't do this if you got a quadratic that doesn't factor. If you got an x up on top, you can't do this. So, even this is really specific when you can use it. Now we'll give you some problems to work on off the ratio and root test. And you can take a break then if you want. If you're more comfortable doing it at home, I don't have any problem with that, but I'll give you time during class. And then the question becomes, next time we'll finish up chapter 9. You want to test on Tuesday or Thursday? How many people want on Thursday? 3, I guess 4, so we'll have it on Thursday. If you don't got your book with you and you want to work on these during class and take a picture of it, But number, let's see, 8, 10, 12, and 14.
For the homework, right?
Right. Yeah, there won't be any quiz off this. Well, like I say, if you want to do it at home and email to me, you can do that also. Because I recognize some people were freaked out about the COVID virus. So president getting it, and then I don't know if you heard or not, but they have